Hello and welcome to this fourth and final mole conversion video. We're going to talk about going between moles, mass, volume, and pieces. So we've taken a look at these in just 2 bits at a time, so going between just 2 of them. Now we're going to look at the possibility of going through all of them. And so here we have this mole organizer. And so on the mole organizer we have mass, moles, pieces, and volume. Okay, and so we know that the direction that the arrow goes is going to be corresponded to whatever the conversion factor is. Remember, if we go in the opposite direction, so say I was to go in the opposite direction of this, so if I go this way, I'm going to just flip my conversion factor, and so I would have molar mass on the top per 1 mole on the bottom. And that goes for all of these. So whatever you do in the reverse direction, you would just reverse the conversion factor. So this one would be 6.022 times 10 to the 23rd, Avogadro's number, pieces over 1 mole. And then of course in the opposite direction here, this would be 22.4 liters over 1 mole. So this is just a diagram that I like to use to organize myself as I work through these conversions. There are some other ones that are out there that people use, and so those are different entities that you are able to use for these. So let's go ahead and take a look at some actual conversions. So here's the first one. So in this one we're going between mass and pieces. So we're going to start off with our pieces in this first one. So we have molecules. If we're going between mass and pieces, we need to know our molar mass. And so if we remember how to do our molar mass, so CH4, 12 grams for carbon plus 4 times 1 gram for hydrogen, and that's going to give us a total of 16 grams per mole. Okay, so we just go ahead and set that up. We have 1.7 times 10 to the 24th molecules. Okay, and you might go, well, wait a minute, we can't use molar mass yet. No, we can't. So we're starting at mass. Okay, we're starting here, or excuse me, we're starting with pieces. Let me find, we'll do yellow. We're starting with pieces. In order to go from pieces to mass, we're going to have to go this way first, okay, using this conversion factor first, to moles. And then once we've reached moles, in order to go from moles back to mass, we're going to have to use this step second to get to mass. Okay, and that's kind of how I use this diagram, so you can kind of go back and forth. So let's go ahead and come back here. So the first thing we need to do, we have molecules, we need to cancel molecules. And in order to cancel molecules, we have to put Avogadro's number on the bottom, 6.022 times 10 to the 23rd molecules, MLQS, for 1 mole. Okay. So molecules cancel. I'm left with moles. Whatever is on the top in the previous step is what goes on the bottom in the next step. So now I want to go from moles into mass, and to go from moles to mass, I use that molar mass. Okay, so now for every 1 mole, I know we had a mass of 16 grams. Okay, the math on this, multiply across the top. 1.7 times 10 to the 24th times 16. Okay, that's your first thing. Then multiply across the bottom. Well, Avogadro's number times 1 is still just Avogadro's number. Anything times 1 is just still the same number. Okay, and then we're going to divide the top by the bottom. So that's how you do this in your calculator. I'll show that a little bit more step by step in class. I can't dual screen or multitask when I'm recording. It won't let me do that here using these applications. Okay, so moles cancel. I'm left with grams, which is mass. That's what I want to know. So when I go ahead and calculate this, I did that ahead of time, and I got 45 grams with sig figs, 2 significant digits, so 45 grams. Okay, that is my answer. Now let's work the opposite direction. In the second one, we're going to start with grams, and we want to know formula units, which is pieces. So we're just going to work the opposite direction. So we're going to start with 95.1 grams. Okay, we already know that we had 16 grams. Oops, sorry. That is for MgO. So Mg is 24, O is 16, so this should be 40 grams per mole. So 40 grams per 1 mole. Okay. Now, for the next step, for every 1 mole, so I want to cancel what was on the top in the previous step. Okay. I have Avogadro's number, so 6.022 times 10 to the 23rd formula units. So let me double check. I always like to double check my units and make sure they cancel properly. So grams cancels grams, moles cancels moles. I'm left with formula units, and that's what I want to have. So that's perfect. Okay, so multiply across the top. So 95.1 times 6.022 times 10 to the 23rd. Do that first in your calculator, then divide by 40. And when I did that, I got 1.43, 3 significant digits in this one. Okay, we had 3 in our original value from our problem. So this one is 1.43 times 10 to the 24th formula units. Okay, so these are 2-step conversions to get to the other one. Let's go ahead and try some additional problems. So we're going to start with grams. Okay, which means we have to have molar mass again, and we want to go to volume. So now we're going to start with our 124.8 grams. Oxygen is 16 grams for 1 of them, so 2 of them is going to be 32 grams per 1 mole. And then to go to volume, which is liters, we're going to have for every 1 mole, there's 22.4 liters. So grams canceled, moles canceled. I'm left with liters, which is what I want to know. I want to know volume. And so when I do this calculation, which I did ahead of time, I get 87.36, 4 significant digits for this one. There are 4 sig figs in our original value. So 87.36 liters. Now we want to work the other opposite direction. So in the second example, what is the mass if we start off with 57 liters of N2? So now we're going to start off with 57 liters. It does not matter that it's N2. We're just going to assume it's ideal gas at standard temperature and pressure. So we're going to go 22.4 liters for every 1 mole. Second step is where we're going to need our molar mass. So for every 1 mole, that's going to go on the bottom to cancel the moles on the top. Nitrogen is 14 grams per mole. 2 of them is going to be 28 grams per mole. Okay, double check. Moles cancel, liters cancel. I am good to go. And I end up with 71 grams with this one. So let me go back. 71, 2 significant digits, grams. Pre-calculated, of course, for you. So we just end up flipping those conversion factors the opposite way. I always like to just check and use those units in order to help me solve these problems. I hope that's helpful for you, and we'll take a look at more of these in class.